The Analytical Biochemistry Shared Resource offers a wide range of valuable services. Mass spectrometry services emphasize trace analysis of metabolites, DNA adducts, and other biologically important compounds. An array of small molecule and macromolecular analyses are carried out by liquid chromatography or gas chromatography coupled to mass spectrometry.
Our research focuses on cancer prevention, particularly as it's related to tobacco, and our main interest is finding the susceptible smokers. We want to understand what factors make certain people susceptible to the carcinogenic properties of tobacco, while others can smoke for many years and never get cancer. Only about 20% of heavy smokers get lung cancer. In order to identify those smokers, our approach is to analyze the tobacco metabolites that are present in their urine or blood. The profile that we get can will potentially differ among smokers. It does differ among smokers. Some smokers have greater amounts of the cancer-causing agents in their urine than others, and we believe that those smokers are more highly susceptible. This is not trivial work to do because even though there are multiple cancer-causing compounds in tobacco smoke, the daily dose of each of these is very low. So the amounts of the metabolites in urine are extremely low. And urine, as you can imagine, is an extremely complex mixture of many different chemical compounds. So in order to find and measure these particular tobacco metabolites, we need mass spectrometry. Without mass spectrometry, these projects would simply be impossible to do.
The core in particular provides expertise in cutting-edge mass spectrometry techniques. We have state-of-the-art instrumentation, high-fidelity instruments that are rapid scanning instruments, highly sensitive, that provide accurate mass measurements. It requires the skills of professionals such as people at the Alta to maintain and optimize the instrumentation's performance in order to be able to successfully measure these analytes which are present in trace levels.
The core provides instrumentation, both LC triple quadrupole and GC triple quadrupole services for quantitation of thousands and thousands of samples to support this rather large PO1 effort, which consists of 5 different components with a variety of different PIs. And we provide both the instrumentation and the training and troubleshooting all of that to make sure that the analysis are done properly and they get accurate numbers to do the science.
Without the analytical biochemistry core facility that has all of the mass spectrometers, we would not be able to do any of this work. So one example of work that we're doing that's supported by the analytical biochemistry core involves the difference in susceptibility to lung cancer among different ethnic groups. We know from epidemiology studies that African Americans are more susceptible to lung cancer than whites for the same number of cigarettes smoked, and whites in turn are more susceptible than Japanese Americans. And we're using the analysis of the urine of more than 500 subjects per group using mass spectrometry for the analysis in order to identify these differences. And what we've found is that African Americans take in more nicotine and more carcinogens per cigarette smoked than do whites, and whites in turn take in more nicotine and more carcinogens than do Japanese Americans. And these findings, which are unique and which are completely dependent on the analytical biochemistry core facility, explain why African Americans get more lung cancer than whites for the same number of cigarettes smoked, and whites get more lung cancer than Japanese Americans.